Okay, this video is for AP Statistics. This is going to be part 1 for Unit 2, which is Chapters 7, 8, and 9. We teach those chapters together, and then we cover Chapter 10 separately, and then that's the end of that unit. This second unit on two-variable data is a little bit more involved than Unit 1, so usually people find that a little bit more challenging. Make sure that you're asking a lot of questions if you don't understand things. Around in tutoring after school every day except for after school Wednesday, before and after school. So come and see me if you need any help, right, understanding this stuff. This first part, we're going to break this into 4 parts. Chapters 6, 7, and 8 are all taught to, or 7, 8, and 9, sorry, are all taught together. We're going to break it into 4 chunks, and this first chunk is on Friday, right after we took the other tests. So this one will be a kind of a gentle introduction, and then it'll kind of ramp up in difficulty. And I'm going to share my entire screen here because this section, this unit, is highly calculator intensive. There's very little you can do without the calculator, so you'll definitely need your calculator to get all this stuff. Okay, so we're going to start talking about the Unit 2, which is really about correlation and linear regression, but it's about what can you do when you have data set that has 2 different variables for every piece of data, not just one. So like an X and a Y, okay? And actually what we usually do on the first day of this is that we go collect some data that we use. So since we're virtual right now, we don't have the opportunity to do that, but basically what I do is I have people form a line, just so I can describe what we would have done. And I put 2 pieces of tape on the ground that are pretty far apart. So all the people are standing on one of the lines here. We go out in the courtyard, or actually in the breezeway. And then I just have everybody walk from one line to the other and count how many steps it took for them to cover that distance. And then they walk back and count it and then average the 2. And we have every single person do that. So for every person, we have 2 pieces of data. We have how many steps they took, right? But then I also ask them to write down their height in inches, right? So we have actually 2 different things. We know the number of steps they took, and we also know their height. And then the idea is that we might want to see if we could predict how many steps somebody would take to cross this distance if we knew their height. In fact, if we were to put height down here in the X, and then the number of steps that they took to cross that here, right, we might see that the taller someone is in general, right, since their legs are longer, they take fewer steps, right? So maybe we would see that, like, this particular person has a particular height, maybe they were short and they took a large number of steps, but somebody that was really tall, they might take a smaller number of steps, and then we would have a dot here for each person's height and steps. So every piece of data actually has 2 pieces to it, an X and a Y. This is referred to as bivariate data. 2 variables, bivariate data. So that's what this unit is about. It's all the different ways we can analyze variables where every data has 2 values associated with it, not 1. Okay, we focused on a single variable in the last unit, and we either had numbers or potentially we had categories or something like that. And so if we were to consider our height and step data that we took as a class, which I'm going to show you in a second, we could do things like make histograms to display either variable individually. Like I could just look at just the height versus frequency and get the heights of people and say something about, you know, most people are sort of in, you know, this range, find the IQR, heights are skewed right, that kind of thing, right? Or we could look at the number of steps. So we could look at each variable individually, right? But that ignores the fact that there's a connection between a particular number of steps linked to a particular height in the data set. So what we're doing in this unit is talking about that connection. Okay, so if we were to plot the height as, say, the X variable, and then the number of steps as the Y variable, every one of these dots represents a person. And our main tool to visualize bivariate data is something called a scatterplot. So it's just that. You have 2 variables, an X variable and a Y variable, always from left to right increasing and from lower to top increasing. And then you put an individual dot somewhere on that XY coordinate system that indicates that linkage between the X and the Y. Okay, so that's called a scatter plot. And here is a set of data. Well, actually, we'll show you how to enter that in a second. So you know how we had, when we were talking about one variable data, we had SOCS as our acronym for describing a distribution of values across a data value. Well, there is a way to describe relationships between X and Y data, okay? And from looking at the scatter plot, we can get a general idea of some things, right? One thing we can get is the direction of the association. In other words, if one variable goes up, does the other variable also go up? If that's true, and we see an upward slope, a positive slope here, then that means we have what's called a positive association, right? On the other hand, if when one variable goes up, the other variable has to go down, which means we have a negative slope. If that's true, then we say we have a negative association. And if we can't discern any trend, like there's no way we could really draw a line, or another way to say it is that there's variation in Y, but I can't connect it to the variation in X. It seems to be independent. So, you know, there's basically nothing. You could almost associate that with a zero slope. Then we would say there's no association at all, right? So this is referred to as the direction of the association. So if we're describing an association, we're going to say the association is positive, negative, or there isn't an association, okay? Okay, and then the other thing we're going to talk about is the form of the association, right? You might have something where when you connect these, there is either a positive or negative association, but if you were to kind of try to draw some sort of a curve through that, that would in fact be a line, and then we call that a linear association. If there is some connection, but the connection doesn't form a line, we say just that it's a nonlinear association, okay? So that has to do with what we call the form. So we have the direction and the form, and then the last piece is the strength. So if you were to fit a line through the data like this, both of these have a positive association, but these dots are closer to the line on average than these dots. So what we would say is that this association is stronger, and this association over here is weaker, and that's the strength of that. So if I was describing an association, I might say something like there is a linear, that's the form, moderately strong, strength, negative, direction, association, and then I would put between steps and height if that's what we were talking about, okay? All right, so that's kind of the thing that it corresponds to SOCS. There's no acronym for it, but we have to talk about the form, the strength, and the direction when we describe an association. And then each of these variables has a role, right, in terms of the X variable versus the Y variable, right? And the idea is that if you can find some kind of an association, like let's say we have this, this variable was steps and this variable was height, then the idea is that if you knew someone's height, you might be able to predict their number of steps, right? And, you know, on the other hand is not true. If I were to try to write this as steps down here for the X variable and height here, right? If a person's steps changes, like if they take larger strides or lower strides, that doesn't change their height, right? The height kind of comes first. They are their height. There's no control over that, but that's driving a change in the steps, right? In other words, if their height is taller, then they have less steps, right? But changing steps doesn't really draw height. So this kind of ordering doesn't really make sense. Now, some pairs of data, it really doesn't matter, right? But if there is sort of a direction where one thing would drive the other and the other can't drive this in that way, then we have to specifically state that this variable here is called the explanatory variable, okay? This X variable is the explanatory variable, right? And the Y variable in AP statistics is called the response variable, okay? So the idea is that the response is responding to the explanation. This is explaining what's happening in the response. Okay, so usually the words we use for X variable are explanatory here, and the Y variable is called the response. Occasionally, the X variable is called the predictor because it can predict something in the response. We tend not to use these things in algebra. They call the X variable the independent variable and the Y variable dependent, but we tend not to use those because for us, dependency has more to do with, is there an association between variables? So we will tend to use explanatory for X and response for Y. So you need to know that the response variable means the Y and the explanatory variable means the X. Okay? All right, and then at this point, usually what we do is we go ahead and do problems number 1 and 2 in the chapter 7, 8, 9 required practice. Because we teach these together, we have a single large packet that covers chapter 7, 8, and 9. Since it's still covering 3 chapters, it's worth 15 points, 5 points per chapter. It's just all grouped together. So I'd like you to pause the video and then go ahead and try to work those problems. Okay, what I'm going to do is go ahead and go over them. That's what we would do in the class at this point. So the first problem says the scatter plot shows the fuel efficiency in miles per gallon and then the weight in pounds of 20 subcompact cars. Is there a clear explanatory variable and response variable in this setting? If so, tell which. If not, explain why not. Okay, so now they chose car weight as the explanatory variable and fuel efficiency as the response variable. And actually, that does make sense, right? Because if a car is heavier, the engine's having to work harder. So it makes sense that that could explain the response in the fuel efficiency, right? But in the fuel efficiency isn't causing the car's weight to change, right? So if there is a cause-effect relationship, this would be the cause, and this would be the effect, okay? So that means that the explanatory variable, that has to be the car weight here, right? And the response variable has to be the fuel efficiency, okay? And then as far as an explanation, I would say because weight increasing makes the engine work harder. So just try to kind of explain why you think there might be a cause and effect relationship, lowering the miles per gallon. Okay, something like that for the explanation. All right. And then the second problem, it says describe the association. So whenever we describe an association, we are always going to just fit a line to the data, right? We're not going to fit curves to things in this class. And you'll see why as we go through this class. So if I were just going to draw a line through there, you know, that line seems to have a negative slope. So I think what I'll do here, let me use a text tool so that it's a little more legible. We can say the association between fuel efficiency and car weight, that puts the context in there, is negative. I would say strong. But most of those points are very close to the line. There's just this one weird point here. But other than that, the points are following the line very closely and linear. Okay. So the fact that you have one weird point doesn't mean that the trend in general isn't linear. So I would definitely say that. That's my description of the association between the fuel efficiency and the car weight. All right. And then I think, let me go back to the notes then. Yeah, that's as far as we're going to take it for the first day. So this is just a quick introduction, but we'll pick this up in part 2.